So the stuff we're going to do here in 5-6 is actually very, very similar to what we did with synthetic division. So we're going to get a reminder of that. So we've got this polynomial function, negative 3x squared plus 5x plus 4. We want to divide it by the quantity x minus 3. So we're going to do a little recap of synthetic division here. So remember the way synthetic division works is we write all of our coefficients in order. So we start with a negative 3, and then we have 5, and then we have 4, and we don't have any gaps. We're not missing any terms, so we just write these right in order. Remember, if you had a gap, you'd write a 0. And then in the box, you put the opposite of your factor here. So since this is a negative 3, we put a positive 3 right here in the box. First step is we bring down this negative 3. Then we multiply negative 3 times this 3 right here, and that gives us negative 9, which we line up right there. Then we combine these up. 5 and negative 9 gives us negative 4. Then we multiply these two right here. We get negative 12. So we line that up under the 4. And then we combine these up and we get a negative 8. Okay, so when I write down my answer, I'm going to write a negative 3, and that would be just in front of an x, because my degree always drops down 1. And then minus 4. And then plus my remainder is a negative 8 over x minus 3. Okay, so in the next step, it says compare the remainder of negative 8, so I was just giving you a little clue as to what our answer is going to be, to f of 3. So f of 3, remember what that means is I take my polynomial up here and I plug in 3 for every x. Okay, so this 3 squared is 9 times negative 3 is negative 27 plus 15, and then plus 4. So this is a negative 27. This ends up with a positive 19. So I add those together and I get a negative 8. Okay, so this is what I was asking you guys to do, is compare the remainder of negative 8 to f of 3. So the remainder when I did division is negative 8. When I plugged in 3 right into the function, I got negative 8. Not a coincidence. This is actually a theorem, and we're going to write that theorem down. So the remainder theorem says if a polynomial, let's just write it. Let's write it down in symbols here. So the dividend, so we've got p of x, which is the big long one, the original polynomial, equals, we say quotient, q of x, times the divisor, which is x minus r, plus p of r, which is the remainder. So this basically says that when I do the division, I'm going to end up with a remainder that's the same as p of r. So let me write just a couple of notes here. So p of x is the dividend. That's the original polynomial, like the long polynomial. Q of x is the quotient. This x minus r is the divisor. And then p of r is the remainder. And we can label them up here if we want. So all these pieces that we have right here, the dividend is the long one. That's like the negative 3x squared plus 5x plus 4. The quotient is the piece right here, like the negative 3x minus 4. The divisor is whatever we divided by the x minus 3, and then plus the remainder. So this is basically saying that the remainder is going to be whatever we get when we plug r into this dividend right here, which is what we just proved. So definition, synthetic substitution is basically the process of applying the remainder theorem to get the value of a function. So synthetic substitution is applying the remainder theorem using synthetic division to evaluate a function. Oops, there we go. Okay, that's what we're going to do right now. So synthetic substitution. If we want to find f of 3, now let's pretend, just for fun that we don't have a calculator, because of course I taught you how to just plug the 3 right into the function if we have a calculator. We're going to do synthetic substitution. So we line up our coefficients. So we've got a 3x squared a negative 3x cubed, negative 6x squared, a 1x, and then a negative 11. And in our little box is where we're going to put the 3. All right, so follow the substitution here. We bring down a 3. We multiply 3 times 3. Line that 9 up right under here. Combine those two together. Negative 6 and 9 gives us 3. So again, we multiply 3 times 3. That gives us 9. Combine these two up. 1 and 9 gives me 10. Multiply these two together. 3 times 10 gives me 30. And then I combine these up. A negative 11 and a positive 30 leaves me with 19. So that's my answer. Whatever the remainder is, that last digit, that's f of 3. And you could always double check, like plugging it into the calculator and simplifying it down. But of course, we are pretending just for fun that we don't have our calculator. Let's do another one. Okay, so we've got a 4x to the 5th. We don't have an x to the 4th, so don't forget about your placeholder. We've got a 2x cubed, a 1x squared. We don't have an x, and then our constant is a negative 1. Okay, and we want to evaluate at negative 1, so the negative 1 is what goes in our box. Okay, so we bring down the 4, and we multiply 4 times negative 1, gives us a negative 4, and then we combine these two up. 0 and negative 4 gives me negative 4. Then I multiply negative 4 times negative 1, that gives me positive 4. Then I add these two together, that gives me 6. I multiply that 6 times negative 1, gives me negative 6, which I line up right here. Add these two together, and I get a negative 5. Multiply negative 5 times negative 1, I get positive 5. Add these two together, I get 5. Multiply 5 times negative 1, gives me a negative 5. Add these two together, and I get a negative 6. So it's that remainder that's my final answer. Okay, and again, you could always check your answer by plugging into the calculator. Okay, so this example right here, we might need a little bit of calculator work in order to figure this out. All right, so the function c of x, we've got 2.4x cubed, all this nasty function here, can be used to approximate the number in thousands of international college students studying in the United States x years since 2000. How many international college students can be expected to study in the U.S. in 2015? So that means we want, like this 2015 means we want x equals 15. So we like to just plug 15 right into this function here. Of course, these are nasty numbers, and so we are just going to worry about getting this set up using the synthetic division. All right, so we're going to line up. We've got a 2.46x cubed, a negative 22.37x squared, a 53.81x, and then 548.24, and we are going to divide that by an x minus 15. Okay, so here's the first thing that we do. I want to make sure. Oh, of course I don't have a calculator on me. Gonna have to pause. Okay, got my phone. That's the best I can do for right now. So we're still going to follow the same process. We're going to bring down this first digit, the 2.46, line everything else up, and the process works exactly the same. This way we can just do it pretty quickly with our complicated numbers. So we've got 2.46 times 15. That's what we're going to line up under the next one, so 36.9. Combine that with a negative 22.37. That gives us 14.53. Okay, next thing we're going to do is multiply that by 15. Okay, and that gives us 217.95. And then we're going to combine that with a 53. Whoops, no. Okay, let's try that again. So 53.81 plus 217.95. Okay, we get a 271.76. Okay, and then finally multiply that by 15, and I get 4,076.4. Okay, and then add those up. So add that to 548.24. Okay, so I get this nice value right here. Okay, and then if we read through carefully, approximate the number in thousands of international college students. So how many were you expecting? So we want to turn this into thousands. Okay, so this is going to be 640 instead of 0.64. Okay, so that would be an approximate number for that value here. Okay, so we're going to move into our last little bit here. This is something called the factor theorem. This helps us try to figure out what the different factors of polynomials are, because a lot of times we're dealing, as you saw with the last lesson, we're dealing with these polynomials that are not super easy to factor. And so for factors of polynomials, what this thing called the factor theorem tells us is that the binomial, the binomial x minus r is a factor of the polynomial p of x if and only if p of r equals 0. Okay, so once we get that written down, I'm going to explain it a little bit. It's not crazy complicated. It's a little bit weird to understand. So what this tells us is that the binomial, so x minus r, let's say it's like an x minus 4 or an x plus 3 or something like that, says it's a factor of the polynomial if and only if p of r gives you 0. What that means, because remember we've been talking about this remainder theorem, this means that there's a remainder of 0 when I divide it in. So if I try to divide in this binomial, I get a remainder of 0, which means it divides in evenly. And so if it divides in evenly, that means it's got to be a factor, because I don't have a remainder of 0. Think of something like super easy with numbers. Like if I took 48 and I divided it by 7, I'd get a remainder. But that's because 48 isn't divisible by 7. If I took 48 and I divided it by 6, my remainder would be 0. That's because 6 is a factor of 48. So same thing with these polynomials. If I divide a binomial into a polynomial and I get a remainder of 0, then that means that it divides in evenly. Because remember, p of r represents the remainder. So let's test this out. So determine if x minus 2 is a factor of this polynomial. Okay, so we're going to do synthetic division, see what our remainder is. If our remainder is 0, that means it does divide in evenly. So let's line up. We've got a 1x cubed, a negative 7x squared, a 4x, and then a positive 12. And so we're going to divide by this factor. So x minus 2, that means I put a 2 in right here. Okay, so follow our steps. We move down the 1 first, then we multiply 1 times 2, we get 2. Then I combine these two numbers up, I get a negative 5. Multiply negative 5 times 2, and I get a negative 10. Add these two numbers together, I get a negative 6. Multiply the negative 6 times 2, and I get a negative 12. So there we go. We end up with a remainder of 0. So the next part is we want to find all of the factors of the polynomial. So we know that we have an x minus 2. We just divided that out. So let's write down the rest of what we have here. So then we have a 1x squared. Remember, if we started out with a cube, we drop it down 1. And then minus 5x minus 6. So that's what we get when we divide out the x minus 2. Meaning that this polynomial, let's write a little side work here, this polynomial is x minus 2 times x squared minus 5x minus 6. Okay, so it's kind of like they gave us one of the steps of factoring. Now we can take this piece right here and we can factor it down even farther. So we've got the x minus 2, and then we can factor this piece on the right-hand side down even farther. So x squared, we start with x and x, and then we want to know what multiplies to a negative 6 and adds to a negative 5. And that would be a negative 6 and a positive 1. Okay, so this is the complete factorization of this binomial right here. So if we want to find all the factors, this piece right here gives us a factor of 2. This piece right here gives us a factor of 6. And this piece right here gives us a factor of negative 1. Okay, so those are all of our factors. Okay, so kind of a short one for you today.